about time, so I will just start talking. The first 2 minutes are just kind of introduction. So thank you very much to this session. My name is Davor Gornik. I'm now from the company Dell Technologies, Dell EMC, but we changed the names. We are still the same people. You see us on all of this as EMC Square, which was our name before the merger. Basically, let me start here about explaining a little bit what's behind this presentation. So, we actually, as a team, work on a larger OpenStack project that results in an OpenStack appliance for now about 2 years. We have this appliance in production with several customers so official first GA was in March, and yeah, this would be great, thank you. And we just released the version 1.1 of this appliance, which upgraded from the Kilo release to Mitaka release, and we did, in this transition actually, we changed our networking from a classical Neutron single node implementation to a Neutron.DVR implementation. And this is basically what the presentation is about. What does this actually mean for us? What did it mean on the work side, and what did we achieve? Does it really scale better, or what problems did you solve? You see the name of the product. If you want to know anything about the product, we are outside, talk to us, but this will not be part of this presentation, okay? It's just about technology. Who am I? I am one of the product managers on the product. So I've worked with the company now for a little bit more than a year. I came from another, a little bit bigger company with 3 letters called IBM. Was responsible there for some appliances in pretty much the same area. And have quite a long history of open source. For example, one of my teams was initial contributor to Eclipse and stuff like this. So dealing with open source since 99, 2000, these are pretty much the years where we started in this area. At that time with rational software that became IBM and so on and so on. Enough of introduction. So let's look at the starting point. This is pretty much what we achieved with our 1.0 version of the product. We had the complete hardware configuration, includes hardware networking that we deliver within the appliance. It's pretty much spine leaf configuration of networking, several racks. Each of the racks have top of rack switches, and then each node in this rack is connected to top of rack switches. We connect several racks together with aggregation switches that go across racks. Simple implementation, no magic behind it. You can do it with pretty much any brand of switches. We actually tested this with 2 brands of switches, Arista and Cisco. Currently we are using Cisco, but there is really no preference. The reality why we are using Cisco is because they're cheaper than Arista for the same functionality, which, by the way, surprised us also. We have in the system 3 management nodes that pretty much don't do anything else but run the complete configuration. So those are not the nodes that actually run the VMs from the customer. Those are the nodes that deal with things like the basic OpenStack configuration, the basic OpenStack deployments. Those are the nodes that deal with getting all of the configuration files together, synchronizing them across the nodes, dealing with HA capabilities of the product. This is where you do all administration on, okay? And then we have compute nodes. And compute nodes, they can be many. You can just push new hardware in, deploy a new compute node. Management node, we recognize there is new hardware. We recognize what kind of the hardware is, and we'll deploy basically on this compute node, Nova and Neutron client, and all of the stuff that you are deploying there. There is a lot more behind this implementation, but all of this is kind of not part of this presentation. I just want to explain a little bit what our situation here is, okay? Like I said before, we had this on the Kilo release in the 1.0 version. We have it on the Mintaka release in 1.1 version. And by the way, the update from Kilo to Mintaka on a running system takes less than 1 day. It's very, very quick across all of the nodes. In the 1.0 version, we already solved many, many problems that you typically have. One is physical high availability of the networking. So every network path we have from every node up to the customer network is doubled. So we have two network ports in parallel at every node. We have 2 sets of top-of-rack switches. We have 2 sets of aggregation switches, and they're all cross-connected. So anything physically can fail, and the only thing you will see is reduction in basically the throughput, and that's it. We used Neutron in the 1.0 version, standard Neutron implementation, and I will go a little bit over it and what actually the concerns were with this standard Neutron implementation, which is pretty much a single node implementation, where you are running Neutron on this single node, and everything that goes from customer VMs to the external network has to go to this one single node. We use Keystone-based network separation, which pretty much means different projects in Keystone had different software-defined networks. They didn't have any overlaps. If you wanted to communicate between them, you had to define a router, which pretty much means, once again, you had to go over this one specific Neutron node. We have solved the problem of high availability. So basically, we are running, remember we have these 3 management nodes. We have 3 management nodes because we are running on one of them an active Neutron node, on the second one a passive Neutron node, the third one has a tiebreaker between them, and we are doing heartbeat between them, so this is how we solve the HA availability of Neutron in the first version. And simplified updating between versions, not part of this presentation, but basically we are doing the complete OpenStack deployment on top of Docker, which simplifies our updates extremely. But this was the 1.0 version. And let's go a little bit into details. So this is how it looks like. You have the customer switches outside. This is a physical representation here. On the 40 gigabit switches are actually the aggregation switches between the racks. And you see the connections from 40 gigabit switches to 10 gigabit switches that are top of rack switches in every rack. And then from 10 gigabit switches, you have connections to every node in the implementation. Okay? No magic here. Completely level 3 network. A little bit of magic that we are doing in the background is not on this picture. We actually separate the complete management flow. We have a completely separate management network that's a 1 gigabit network because this is enough. Okay, just brings you some benefit in throughput, nothing else. And cost a little bit of money. Whenever we have, this is the node on the left side. When you're looking at the node, you have 2 10 gigabit pods. They're bonded together, which pretty much means we can run 20 gig theoretical network load on every node, okay? Because we are using both nodes together, we are actually physically going, distributing the load between those 2 nodes, so we are achieving a little bit more throughput. Bring some benefits in the 1.0 version, and we will talk a little bit about the 1.1 version with DVR, where this actually brings way more benefits than before. And you see at the bottom, the 1 gigabit network, this is the management networks, just for a completeness of this picture. This is all on the physical side. When we are looking at the high availability, that we talked about in the 1.0 version, so before DVR. We solved it. We have one platform node. This is the active one. This one works, which pretty much means every agent on every deployed node is connected to the active Neutron node, and every communication goes through this active Neutron node and then one to the out to the external network via the layer 2 routing. That's it. Between them, between the two platform nodes, we actually have several things. One is the pure heartbeat, which pretty much is saying actually we are doing it every second. Are you alive? Are you alive? Are you alive? Are you alive? We are running this through the management network, so it doesn't have any influence on our data network altogether. If it discovers at any point in time you're not alive, it will not immediately switch over. We need 3 wrong pings before we switch over, because we figured out that from time to time you will have false alarms because of whatever. There is just a lot of load on the first node, and it cannot respond in 1 second for whatever reason. So we are delaying this a little bit, but we have a 3-second response time. When this health check doesn't work, we will initiate the process of transfer. The second thing is we of course have to synchronize the metadata between those nodes. And we are doing this. We have a pretty sophisticated network there with queues, with database replication, with file system replication between all 3 nodes. This is basically what we are doing here. So if the first node fails, what we are doing is actually we are dynamically assigning the same address to the second node, immediate switch over, and that's pretty much it. We don't need even to update the agents on the bottom because we are just assigning a different IP address. It works very reliable. So we do this now in first in beta systems, then in production systems with customers all of the time. Not a single test failed on this area. Neutron works very reliable in this configuration. Okay, no problems here. Here is a little bit of explanation. It's just a question here into the room. How many of you actually implemented Neutron networking? Okay. For the ones that don't, when you are working with a classic Neutron implementation, so the default implementation pretty much that still sadly about I think in the last survey over 60% of customers are still using the default one node implementation. But this is basically what happens. If you have different nodes assigned to different private networks, we have here 3 different private networks, and you have then VMs deployed on this node. They will logically work across nodes on the same network, which pretty much means they get assigned IP addresses, they get assigned routing, and so on within the network. Whenever they have to go outside of this network, they will go over the Neutron gateway. This Neutron gateway is on one specific node. This Neutron gateway is on the active platform node. This is the only node that has this Neutron gateway. This is the default implementation. And from there, they will go to the customer network, or from there, they will go to another logical, isolated private network, if they need to. Okay? What does this mean? It doesn't matter how many nodes you have at the end, your bottleneck is here. Now, because of the flexibility of the system, I mean, theoretically, you could do this Neutron node very, very huge. I mean, 100 gig network and so on. But whatever you are doing, you will have a top here, and this top is not movable. Because we are doing this flexible in our implementation, you can actually use any node as a platform node at any point in time. This is actually, in our case, just 2 times 10 gig. This is maximum we can run here. That we have external switches that could run 1.9 terabytes over them, it doesn't matter. You are limited to this, okay? Let me show this a little bit more in details. Just turn the picture around. What you had at the bottom is now at the top, okay? Private network 1, private network 2, private network 3. When you are between VMs in the same tenant, you can do direct communication, okay? You don't need to go over this gateway. When you are going between VMs in different tenants through L3 gateway, you are going there, and you are hitting with every traffic 2 times this node, because it has to go to the node, it goes from the node, and you have software-defined routing between them. So you are using this node with 2 times as much traffic that you are actually sending. And then between VMs and the public network, exactly the same. Level 3 networks, 2 times the traffic because you're going to the node and you're going from the node. And of course you have a delay of processing and all of this. That's happening here. So this is where we, not exactly with customers, but this is where we, with our testing, we saw immediately there is a scalability problem. I mean, if you are scaling, if you have an implementation of, let's say, 10 nodes, you probably will not hit something like this, or 5 nodes, or 10 nodes, or whatever. But if you are scaling beyond 100 nodes, 200 nodes, and so on, this is a serious concern, okay? Especially because typically when you are dealing with bigger systems, with larger systems, you will have a lot of connectivities that come from outside. Not just because there are external customers dealing with this, but you might have an object storage that's outside. You might have some other kind of storage that's outside. You might connect to some databases that are outside of OpenStack, and so on, and so on. So because of this, we actually had a lot of internal discussions and said, you know, what can we do? And we looked at different technologies, and we saw theoretical benefits of DVR, which pretty much would mean instead of having, oops, sorry, let me go into the other picture. Instead of having here a Neutron gateway as a center here, you can move this gateway and distribute it on all of the nodes, pretty much. That's the short description. You're just parallelizing the gateway. It's a completely software solution, okay? There's no change whatsoever you have to do on any hardware side. Same spine leaf hardware construct. Same number of network cards. Everything else is same. You might have, if you lock down your system with security protocols, you might have to loosen the security a little bit because with DVR, then every node will be communicating to outside. That's the only thing you would have to do between those two. So let's go into the DVR implementation. The other thing that you would do, and just ignore some of the names there, you have to actually now deploy more of the software on each individual node, because the compute node itself will now have to have the OpenWIR switch and Neutron agent and DVR agents on. Okay, so it's a little bit of a logistic problem. At some point in time, you will have to have a process how to deploy this on your nodes. But realistically, we had a process before that already deployed Nova and Neutron and basic stuff on those nodes, so we just had to add new technology to it. It was work. It was not something that we had to invent new concepts. And then reconfiguring everything together from a single node Neutron implementation to a DVR implementation. Until we got this running in our system, in it was about 2 weeks of work. This was all. And this was with all of the testing, this was with applying new security protocols. It was 2 weeks of work. And then, of course, because we are doing a product, I didn't mention this as specifically at the beginning, but if you are doing a product, you have a little bit hardened testing compared to an individual implementations. So our testing actually was several months until we got this approved. But basically what I'm saying here, going from a single node implementation to a DVR implementation, is a mini step compared to all of the other changes you do in other projects in OpenStack. This is really a mini step. You're changing configuration files, you're deploying some more software, and that's it. Okay? And how does this work now? If you are using a floating IP, every node is able to communicate directly to the external network. Okay? There's no different things. If you are communicating from one network to another network, this arrow is actually missing here, but you pretty much are going directly from one node to another node. There's no common gateway anymore. Okay, if you are not using a floating IP, if you are defining a fixed IP, you will still use SNAT and you will go over level 3 gateway. So in this case, you have to understand what the limitations are, and you have to use the right kind of networking for your VMs. If you are using occasional access to the public network, yes, do this, not a problem. But anything that will go into severe networking access, use the standard floating IPs and use DVR, and you will have the communication from inside out. So those slides are a little bit animated, so you will not see them on the PDF print that you will see later, but basically, pretty much the same picture as before, different colors. We like the colors differently always. Node 1, platform node. Platform node is where we still have the Neutron gateway on for SNAT. Node 2, we have a VM1 on the first network. On the first node, we have VM4 on the second node. We have a DVR implementation between them. When we communicate between them, we start from VR to DVR, bridge, goes to the public interface because it discovers it's not on a node, goes directly to system switches, goes to the public interface of the second node via bridge DVR to the VM. Direct communication. We did not touch the platform node at all. Okay? Which pretty much meant, so two things that are happening here. We are not going to the platform node, which pretty much means we don't have the network load there. And this was the only place where we had the double networking node of coming in and coming out. Now you have a single load here and single node on node 2. So you are actually reducing altogether the amount of traffic by 50% that you have in your network altogether. Okay. If you are going to the external network, VM1 through DVR, bridge, public, system switches, external network. Directly out. We are not on the platform node. Once again, extremely direct way, single traffic. In this case, just imagine now, before you were going from this node to the platform node and from the platform node out, you actually reduced the network traffic now by 66% in this case. So a huge difference in the load altogether. And then, I just saw the typo, but it's saying 2 times example 3, sorry, before it was example 2. If you go now without floating IP, you will still go to the platform node, and actually the last arrow is once again over the bridge, public, and so on and so on. So you have 3 times the network traffic here. This is why we are saying here, recommended for VMs with minimal external network access requirements and nothing else. And typically this will be the guys from your company that will say, oh, but I don't want to change my application. You know, I really am not equipped to handle your new stuff. Believe me, after 6 months, they will be equipped to handle the new stuff, and they see how different this is in performance. So, how about high availability? There is absolutely zero change from the previous implementation, okay? We once again have exactly the same heartbeat between the nodes. If the first node exists, okay. When the first node goes down, we switch onto the second one, switch the IP over, everything continues to work. You're doing exactly the same heartbeat. We had zero change on this part. And this is really amazing. I mean, we went into the DVR project with the expectation that it will take us between 2 and 3 months to actually implement this. And then our network guy, which, okay, he's a genius, I have to say this. It's not a normal guy, even between the gigs. But he came back within 2 days and said, it's running. I have some small problems, but it's running. And we looked at him like, just a moment, you said 2 months. This is 2 days. And really, he eliminated every problem out of it in less than 2 weeks altogether. And nodes, of course, there are many nodes at the end. Okay, let's go to performance, because this is the interesting part. And here I will say 2 things. Number one, while we know how to test performance on some things, we are not the big specialists in performance testing. So the results I'm showing here are internal measurements, okay? We run the load before, we run the load later. We compare this a little bit in our test systems. We just started working with an external company that will actually do our real benchmarking of the system and will get us more precise numbers. But here is where we started. Our test configuration, 2 completely separated OpenStack environments, okay? They were identical, so both sides were identical. Doesn't matter so much. 2 times 40 gig physical networking between those 2 environments, okay? We actually had just 1 switch between them. They are in the same physical location. Those 2 racks actually are about 40 feet from each other. That's it. We had 4 compute nodes, so without counting the management node, 4 compute nodes, each node 16 cores, 256 gigabyte RAM, 2 times 10 gig networking, and of course we still had inside of the system between 40 gig switch, top of rack switches and then connection to those nodes. Okay, but this is kind of the physical implementation that we had here. We also had, just if you want to know, SSD storage and so on, but the storage doesn't play into this at all. 3 additional management nodes, and we run on those 4 compute nodes 30 VMs to 30 different hosts. So basically, each system had 30 VMs, and they communicated one-to-one across the systems. This is pretty much with what we did. And all of the communication was networking. We didn't do anything else. So we didn't write to disk, we didn't do any computation or anything like this. Just pure networking. We wanted to know what is the physical limitation here. So before DVR experience, like I said before, every communication was sent from and to compute node. effectively, we had at least 2 network communication per neutron node for each send and receive, in some cases even 3. And we had saturated our network at under 10 gig per second. So it was actually in the area of about 8.2 gig per second. This is the maximum that we achieved between those two systems. We didn't have any bottlenecks on the hardware anywhere. The only bottleneck was the single neutron gateway. Okay, this was the bottleneck, and this just blocked everything here. Then we implemented DVR, which, like I said, software update, no reconfiguration of anything else. And here is what we got. We got about 65 gigabits per second in same configuration, 4 nodes to 4 nodes, 30 VMs to 30 VMs. We actually scaled beyond these 4 nodes. We went to 6 nodes, 8 nodes, and so on, and it scaled pretty much linearly. So if we were at 98% of theoretical linear speed between the nodes when we increased the number of nodes. We didn't test it yet before 8 nodes internally. Okay? Our assumption is that the scaling will go almost linearly across this. We are actually now in the process to build a system with about 180 nodes to test this on a really large scale and see at what point in time we actually hit the bottleneck of switches, because this will be kind of the next layer. And our switches, I said before, theoretically they can do 1.92 terabyte of traffic, but of course outside you are still 2 times 40 gig. Actually we can go up to 16 times 40 gig, but that's a different story. The other thing that was very interesting, we actually measured the load that we are processing on the neutron node itself. And just to be clear, this neutron node runs a little bit other stuff also from OpenStack, but we estimated at that time it was running about 85 to 90% of neutron only load. Everything else was processing log files and stuff like this that happens in the background. In the first case, we had a neutron load, so the processing power on this neutron node was at over 80%. In the second case, we were under 5%. So the node pretty much didn't do anything. It just did some monitoring of other nodes, and that's it. And this is a substantial change here. The other thing that we actually measured is the load on individual nodes, okay? Because our other concern was now with DVR, how much of the processing power on the node itself will you actually see, and how much the additional DVR routing will take from the node. And the difference between a single neutron implementation to a DVR implementation was less than 2%. It's almost nothing, because the node itself before was doing almost the same job. Just it was sending the data to the gateway, and now it's sending the data outside. Yeah, this Open vSwitch load that you have additionally, it's just minimum. I mean, you can barely see it. So this is kind of the implementation we did. In summary, the throughput benefit is unbelievable. Okay. If I look at this, we can do it with Kilo. Kilo was not so stable with DVR. Okay. Let's be very honest here. With Mitaka release, we skipped Liberty. With Mitaka release, what we are doing currently, DVR is very stable. We didn't see any problems in implementation here. We have first customers running on this. Like I said, the update process even with the update process, with changing from the single gateway Neutron implementation into DVR implementation was less than a day for the customer. They didn't have any networking problems on this level. They had some networking problems with the switches, but this is a completely hardware level. But DVR runs extremely stable. So I don't see a lot of reasons not to do it. The only reason I see not to do it is you're doing some really small implementation that will not hit a lot of networking, and you just want to save the time of basically deploying the software on each node. It's the choice here. As I said, it comes at the cost of implementation, and this is the cost of the implementation. But if you are deploying the nodes at the same time, you have to put some software on these nodes in either case. The question is just what do you put in addition? And yes, don't forget, it's not just putting the software there, you actually have to identify each node from the network perspective. So you have to, after the deployment, you have to actually change the configuration of the node a little bit. Trivial stuff, just work. Okay. So this is kind of our story with DVR. I know I have about 5 minutes here, so please ask any questions you might have. Yes, sir.
If you look inside the DVR software, what's in there? Is it Neutrino plus OpenSwitch plus OSPF, or I didn't quite catch what's in it.
So DVR is actually an OpenStack implementation. So it comes as an option of the Neutron project in OpenStack. It's pretty much a configuration choice that you have there. And the only difference that you have from a single node implementation to a DVR implementation is the different components of Neutron are deployed on different nodes. So you pretty much have to deploy OpenSwitch on every node now that you had just on one node before.
And you're running an OSPF daemon on every
yes.
node. But you haven't written any new software. It's existing software just deployed elsewhere, is that right?
Well, the difference is it's a different version of the software, but yes, it's existing software. Okay. It's not a physically new software. It's different configuration of the same software.
Right. Thanks.
Yeah. Yes, sir.
You mentioned the configuration there with Arista switches, which you were using previously, and the use case where you weren't having any NAPs, so there was no floating IPs. Can you comment on the way that with Arista switches you can actually run the Neutron gateway natively on the switch, so you get forwarding programming?
Oh yeah. Yes, you can. We actually tested this. We decided against it because of the simple reason that we wanted to be open to different switch implementations. It works. We didn't test DVR with it. Okay. So we don't know how DVR works on this. In the simple Neutron implementation, it works pretty reliable. It's scaled pretty well. I mean, you put the Neutron gateway on the Arista switch, and with this you have, of course, different processing power because you are running the gateway in the switch itself. Don't forget that it's a little bit limited, so it doesn't work on every Arista switch. You have to take models that have enough storage and processing power to actually do this. But we did test, and the only reason why we didn't do it is because we wanted to be open to different switches. That's the reason.
So it looks like you've containerized your OpenStack deployment.
Completely,
Did
yes.
you encounter any difficulties doing that? Any
Oh,
lessons?
absolutely. You have to imagine we containerized this deployment more than a year ago. So we had this with Kilo, and so the biggest problem that we have with containerizing is always in the area of persistence and how they implement the communication from Docker implementation to persistent pods. This was one of them. The second is we actually tested different modes of Docker deployments, and one of them was pretty much take every agent and deploy it separately in a separate container. And this actually created a lot of overhead on the container management itself. So when you look at our current implementation, we actually chose to have in each container several agents together. The number of containers we actually have in the OpenStack implementation currently is less than 20, and we are deploying it in 3 containers on each working node, about 20 on management nodes.
So are you containerizing things like OBS itself, or is that?
Oh yeah,
okay.
Absolutely. So there are very few things that we are not containerizing. I mean, there are things on the storage side that we cannot containerize because they have to run as a driver in the operating system and stuff like this. And we are not containerizing things like engines, for example, because it just didn't work so well. Let's say it like this. We didn't find a reliable solution to containerize this. Yes, sir.
Wouldn't it be technically possible to run the layer 3 agent on each compute node if you had enough public IPs and do the SNAT on each compute node?
You could do that, but then you would have the problem of scheduling which exact L3 agent, so which router effectively will be handling the floating IP for a given VM. So effectively what you would want to have then is for the OpenStack to be smart enough to pick the router which sits on the same node which hosts the VM which requires a floating IP, and OpenStack simply is not smart enough to do that just yet.
This is actually something that was scheduled for Newton, but it actually fell out of the release. The smartness of OpenStack, to best of my knowledge. So, not a very trivial problem. Okay, any other questions? Yes.
Just a quick one. Did you use VLANs or did you use overlay networks for tenants?
VLANs.
VLANs.
Okay, thank you very much for being here. I will be here today until about 2 p.m. So if you want to talk to me, please come anytime to me during this time. I am doing co-authoring the next talk in the other room just in 5 minutes. After this, I'm here available. Then sadly, I have to go to the airport and fly to Amsterdam for the next OpenStack day.
Benelux?
Benelux, yes. And then next week, Stockholm and so on. And yeah, I live in Seattle, just a little bit farther away. But else, remember my name. I'm very easy to find. If you Google my name, the first 2 pages of hits is me. So, thank you very much.